Good morning, my YouTube viewers. Crystal here. I wanted to make another video for you. Yesterday I was working on the house price regression Kaggle competition question, and basically what I did was I used an idea that I got from an article on Towards Data Science, where somebody had written in and said that he had reduced the columns and he was able to get a winning score when he reduced these columns and he used XGBoost. Well, I reduced the columns, but I didn't use XGBoost, and the reason why is because at the moment I'm just trying to stick with sklearn because I want to become proficient at sklearn. I think it's important to learn how to use, one library before you move on to the next. So I did it. I followed his advice, and I reduced the columns. And then in addition to that, I experimented with several different models. And you can see here where I've experimented with the models. I experimented with bagging. That gave me a 0.16063. I experimented with Gaussian, gave me a 0.69. I experimented with ADA boost. I got 0.16233. I experimented with lasso. I got 0.46697. And so I experimented with several different models to try to get the best reading. And, I try to use different models. I'll try to work on different models and different estimators, to try to get familiarized with it and try to find the best estimator. So we've got bagging, which is what the recent one I did. We've got Gaussian, which I was really surprised about Gaussian. Got ADA boost, which we actually got a higher accuracy with ADA boost, but with this house price regression, they use a different type of scoring technique. They use what they use is error, and then I use lasso, reduce columns. Well, that wasn't lasso, that was ADA boost. And then I did lasso, which I was really surprised that I got 0.46 on lasso. So what shall we do? What shall we look for? Because it's all exactly the same algorithm with different models. But I'll go ahead and use bagging because bagging was the last algorithm that I used. Sometimes what I'll do is I'll use ADA boost, but I found that bagging actually works just slightly better than ADA boost. And we'll go over this code review. First thing I'll do is I will share it and make it public so anyone can see my code that wants to. So it just says I did it 8 minutes ago and I've got 19 views. So people do actually go on to Kaggle and they check to see which notebooks have come up. And then when they're checking to see which notebooks have come up, they see if there's any techniques that they can use in their program to improve the accuracy. And that's why they say that people who win competitions won't give you their code. And number one, it's because they won the competition. But number two, it's because it's usually a whole bunch of bits of code here, there, and everywhere. So first thing we'll do is we'll read the problem statement. Ask a home buyer to describe their dream house, and they probably won't begin with the height of the basement ceiling or the proximity to an east-west railroad. But this playground competition data set proves that much more influences price negotiations than the number of bedrooms or a white picket fence. With 79 explanatory variables describing almost every aspect of residential homes in Amy's Iowa, this competition challenges you to predict the final price of each home. The Amy's housing data set was compiled by Dean DeCock for use in data science education. It's an incredible alternative for data scientists looking for a modernized and expanded version of the often cited Boston housing data set. So that's our problem statement. So now you know a little bit about this data set that we are working on. So I originally wrote the program on Google Colab, and then I copied and pasted it over to Kaggle because I like to keep the programs on my Google Colab because it's easier for me to find them if I want to go back and look for them than it is if they're in Kaggle. So it was written on Google Colab, and I copied and pasted it onto Kaggle. And as you can see, let's just see, saved it to bagging, and then I'm sharing it. So anybody who watches this video can get a copy of the code if they want to. So we've imported our libraries. That's the first thing we do after we create the program. We imported Pandas, NumPy, Matplotlib, and Seaborn. Those are the 4 libraries that I automatically import as a matter of course. If I need anything else, then I'll go ahead and import it, but I won't when I need it. But I won't import it unless I actually need it. And then what I did is, because I started writing blog posts, and in order to keep my programs nice and tidy, I put the libraries in the cell that I'm using it. So like if I'm using sklearn, then I'll put sklearn in the cell. Or if I'm using, well, sklearn's the only one I can think of right now. But if I'm using another library other than these 4 standard libraries, then I will actually put the import in the cell that I'm working on rather than putting them all at the beginning of the program, because I want everything to be neat for when I write my blog post. So after we've imported our libraries, now what we're going to do is we're going to load and read our CSV files. And since this is Kaggle, what we did was we import DS, and then we were actually loading up the files, the train and the test files, and the sample submission. And then we load our data sets. So we've loaded our train data sets, and you can see it's got 81 columns. It's got 1460 rows and 81 columns. Because one of the columns, I think the final column over here is sale price. And so that's our train file. And then what we want to do is we want to load up our test file. Test file has only 80 columns because it doesn't include the sale price. So now we've got a graph of the sale price, so you can see what the prices are on these houses. And you can see over here, we've got a few outliers. And now we've done a box plot of the overall quality and how it relates to the house price. So generally, the better the quality, the higher the house price. Now what we've done is we've done a heat map. And then what your heat map does is your heat map establishes the correlation. And what this guy who wrote this article in Towards Data Science did is he said that he just deleted everything that had a correlation of less than 0.4. So if you delete everything in the black and the purple range, then you're going to be good to go. So you can see over here where it says the porch and pool and stuff like that, that's almost all purple. So you know that you can delete that because it's almost all purple. And again, here, this is almost all purple, so you can delete that. So if you deleted enclosed porch, pool area, and things like that, then you know that it's not going to affect the value of the house. And then so what this guy did, he said that because he deleted everything of less than 0.04, that he said that he did that he came up with something else. So just showing that to you as a way, like whenever you have a data set that's got lots and lots and lots of columns, then you can delete the columns that have a low correlation. So I did a feature selection, and then so I used the features that he suggested I use. This is what he suggested we use: overall quality, year built, year model added, mass inner area, total basement SF, first floor SF, ground living area, full bath, total rooms above ground, garage cars, garage area. And those are just the columns that this guy used. So I thought, well, if it's good enough for him, it's good enough for me. The only difference was he used XGBoost, and I didn't want to use XGBoost because I just want to concentrate my energy in sklearn to learn as much about sklearn and pandas and numpy as I possibly can. So now what I've done is I've appended the train and the test set together. And the reason why I did that is because I'm just worried that if it's not appended together, that whenever I go to normalize the data, it's not going to work out very well. So that's why I've done this, because I like to use my own code to normalize the data rather than use sklearn's code. And I'm just worried that if I don't normalize the train and the test together, if I normalize them separately, I'm just worried that it's not going to work out very well. So that's why I put the train file and the test file together. I've appended the train file to the test file to make a file called xtote. So now we're going to be working with xtote now that we've made this xtote. So now what we want to do is we want to define x and y, or really what we're defining is xtote and y. Test ID equals test ID, y equals train sell price, xtote equals xtote feature. So we're not really defining x and y, we're defining xtote and y. So we've got our xtote feature. Now what we're doing is we're checking for any null values. So you see that we've got null values in mass inner area and total basement SF, garage cars, and garage area. So those are our null areas. I decided to use an iterative imputer, and that is what is in sklearn. I didn't have to use iterative imputer. I could have just replaced the values with the median value, but I decided that since all of the columns were numeric columns, then I could get away with using iterative imputer. So that's what I did. So I imputed the values using iterative imputer. And then after I imputed the values, then I normalized it. And I could have used like a function from sklearn. They've got a min-max function and they've got a standardized function. I don't know if they have a normalized function, but they do have a min-max function. So But I just wanted to use my own code to normalize it. You can use your own code to normalize, and you can use your own code to standardize. So I decided to use my own code to do that, and that's why we had to have X tote, because I just thought to myself, I thought, well, if I normalize X test and then I go back and normalize train, then the values are not going to be the same. So it's best to take the two files and combine them to make an X tote and normalize it all at once. Because if you're going to use sklearn, then what they're going to have is the first one, xtrain, would be a fit transform, and the next one, xtest, would be a transform. And I thought, well, I'm not so sure about that. I would rather use my own code than sklearn's code if I can. And the reason why is because when you're using sklearn's code, you're not really getting the proper foundation of coding. So you are learning how to code, but you're learning how to code at a higher level. And I think that, oh, well, I want to learn the formulas and find out what the formulas mean before. And so if I can code normalize myself, I'd rather put in a tiny little code to normalize it myself than to use like min-max scaler or standard scaler. The standard scaler would use a different code. So now we're going to split X tote up for training and testing. So row equals len train, so that's the length of your train. X train equals X tote colon row. X test equals X tote row colon. Now we're going to split X train up for training and validation, and we are going to use train test split to do that. But I didn't have to use train test split to do that. If I had wanted to, I could have put in the code myself, but I decided not to because train test split, it's got some neat things in it. So, but if I had wanted to code it myself, I certainly could have. But we used train test split on this. I decided I was going to have a test size of 0.05%, and the reason why is because you want to have as much data as you can possibly get to train on. So I just decided test is 0.05%. Then we selected our model. I selected several models, which I told you earlier, but in this instance, I decided to use a bagging classifier. The bagging classifier only gave me a 97.65% accuracy. I predicted on my validation set, and I only got a 93.44% accuracy. And then I checked my RMS squared, and I got 21,321, so I did get quite a bit of error. And then I made a data frame so you can check your predicted values against your actual values. And now we get to the graphics part of it. This is what the values actually look. So the X-val is the blue line, and the Y-val is the blue line, and the Y-pred are the dots. So you can see where the dots fit in together, and the dots need to fit in as closely to the blue line as possible. And then we have another little graphics where it's all askew. So that's one reason why I think that we had problems getting a low value. Well, we couldn't get 100%. Now we're going to predict on the test set and submit. So we predicted on our test set. We put our test set into a data frame with ID and the sale price. And we converted the data frame to a CSV file. And then we read the CSV file so you can see the values right there. And then whenever I submitted my work, I got a 16063, and that's not my best score. I think one time my very best score was 0.1288 or something like that. So it's hard. It's very hard to get a really good score, and you just have to keep working at it. And as I said, people who win these competitions, they won't show you their code. And they said that, I read somewhere that it said that if they do show you your code, it's going to be just little bits and pieces of code here, there, and everywhere. And so you wouldn't be able to understand it anyway. You'd have to do like reverse engineering. So that concludes this code review. If you like my video, please like, subscribe, and share. I've made the code, I've shared the code, so anybody who knows who I am on Kaggle can get a copy of the code because I'm sharing it. And if you like the work I do and you like my videos and you want to receive more videos, then please press the bell button next to the subscribe button. And if you like the work I do and you want to support me, please, I've left my email address to my PayPal account down below in the description box below. And the reason why is because I don't have enough subscribers, and because I don't have enough subscribers, I can't monetize. But yeah, please tap the bell button if you want to keep receiving videos that I've made, because whenever I make a video, you'll receive a notification that I've made a video, and I give you some good code. I'm not going to say it's great code, but I give you some good code. And thank you so much for watching this video, and I look forward to making more videos for you in the future.